Hello there, Mr. Sutton back with another lesson on the other trig functions. In this one, we'll be figuring out how to approximate values of these with a calculator, and if we're given one trig function, we'll be able to find the other 5 of them.
For our warm-up, you're going to get to use your calculator for sine and cosine. So below, I've given you 2 values of those functions. This one I gave to you in degrees, and this one in radians. See if you can duplicate the answers that I got for these 2 functions, and then try the next 2 below. All right, let's see if we came up with the same answers. So I'm going to show you this on the TI-83 emulator I have here. So first off, we need to make sure we're in the right mode. So go to the mode button, and we're getting something in degrees here. We know that because it's the degree symbol. So you'll notice down here we have a choice between radians and degrees. Make sure you switch that over to degrees, and then quit out of there. And then we'll do cosine of 205.3. Enter. So we get a number about like that, 0.9 and some change, negative. Now we're going to do sine of 2.2. Let's see if we get the same thing there. So let's go back to mode, because we already changed it to degrees. Now we have to change it back to radians. So we've got sine of 2.2 equals about 0.8085. So there you have it. We're going to use the calculator some more, and our next problem has a little backstory. So the ideal slope of a ladder is up 4 feet for every 1 foot out from the wall, like so. Ladders with steeper slopes may topple back when you lean backwards. Ladders with shallower slopes may lose their grip on the ground and fall forward. So what we want to know, which ladder is safest? A ladder with a ground angle of 67 degrees or 76 degrees? Now if we're talking about the slope, that means we're talking about tangent, so let's calculate those. So we're trying to calculate tan of 67 and then tan of 76. Now the good news is that tangent has its own button on the calculator, just like sine and cosine. Let's just make sure that you're in the right mode for this. For our last problem, we went into degrees mode, so let's put it, or radians mode, so let's put it back in degrees mode. And now here's the tangent button, 67, let's try it out, about 2.35 and some change. And then pause the video and do tan of 76. All right, let's see if we get the same thing. Now, a neat little thing we can do here is second, enter, and that just repeats the entry I had before. Let's put in 76 now. About 4.011. So in terms of which one is safer, we said that about 4 slope was the safest, and this is definitely closer to that, so this is a safer angle for a ladder. All right, let's take a look at the other functions, the other trig functions other than sine and cosine. Here's 3 more for us to try out. Now this first one, so we'll do the first one together. This first one, cotangent, first off, this is radians, so let's change back our mode. Yeah, it's kind of annoying. We have to keep going back and forth. And then the other problem is, if you look at our calculator, we have a sine, cosine, and tangent button, but oh no, there's no cotan button. And while we're at it, there's no secant or cosecant button. These reciprocal functions don't have their own buttons, but that's okay, because to find reciprocal functions, all we have to do is 1 divided by the original function. So cotan, that's really 1 over tangent. So on our calculator, we can just do 1 divided by the tangent of 4.87. And let's see what that comes out to. So 1 divided by tan 4.87. And that's about negative 0.1589. Pause the video and try out secant and cosecant over here. All right, now hopefully you went into degrees mode for these, because they're both degrees. And then for secant, we're really doing 1 over cosine of that stuff. So let's do 1 divided by cosine of 101, but it's negative 101, so careful with that. Negative 5.24 and some change. And then cosecant, that's 1 over sine of 75. So let's do 1 divided by sine 75. Bam, 1.0353. So now we can find values of sine, cosine, and tangent and all the other trig functions like a pro on the calculator. We're going to shift gears a little bit now. We're not going to be using the calculator anymore in this lesson. Now you're used to sine and cosine and expressing the other 4 trig functions in terms of sine and cosine. But we also want to be able to express all 6 trig functions in terms of x, y, and r. And we'll see why this is useful a little later. But for now, cosine, you might remember, was x over r. And sine, you might remember from one of our earlier lessons, was y over r. You might even remember tangent, rise over run, is y over x. So now our reciprocal functions are actually pretty easy to get here. Secant, the reciprocal of cosine, is just going to be r over x. You're just going to flip this. And then cosecant, r over y, and cotan, x over y. So in a minute, we're going to give you one of these trig functions, and we're going to tell you which quadrant or quadrants you're in, and you're going to have to come up with the values of the other 5 trig functions. Sounds kind of intimidating, right? But the key here is realizing that all 6 trig functions use the same 3 letters. They're all each some combination of 2 of x, y, and r. And here's even better news. We might remember from a few lessons ago, if you have 2 of those letters, you can get the other one using x squared plus y squared equals r squared, basically Pythagorean theorem. And one other helpful hint as you're doing this, x and y can be negative or positive because they're coordinates, but r is always going to be positive. So if you're trying to pick which thing is positive or negative, r is always positive, and these other 2, x and y, can be negative. So here we go, the moment we've all been waiting for. They're telling us that the tan of some angle is 3 over 2. They're telling us that the angle is between pi and 3 pi over 2. So remember, that's between 180 and 270. That's third quadrant. And they want the other 5 trig functions. So what they're looking for as an answer, they want fractions just like they had here. And some of the fractions might have radicals. Now, what you're not allowed to do usually on these problems is just do like inverse tan of this angle. We haven't even talked about that yet. So you don't need any of that fanciness to get our answers. So first thing we want to do is figure out which of the 2 letters between x, y, and r they just gave us. Now tangent, we know this is normally y over x. So they've given us the y and the x value. But remember, x and y can be positive or negative. So we have to take a look at the quadrant we're in to figure out what the sign is going to be. So since we're in quadrant 3, we might remember that tangent is negative in quadrant 3. So that means that although this looks like a positive fraction, x and y here are really both negative, again, because this is quadrant 3. So x is going to be negative 2, whatever this bottom is negative, and then y is going to be negative 3. All right, now let's go ahead and find the missing letter. We need r to get the other trig functions. There is one trig function you could get right away, and we'll do it later on, but we know that cotan is the reciprocal of tangent, so you could kind of get that one for free. But we need r for the other trig functions. So let's use our Pythagorean theorem. X squared plus y squared equals r squared. So we need then the square root of 2 squared and 3 squared. So that's the square root of 4 plus 9, 13. And then we can use r, x, and y to get the other 5 functions. Let's start with sine. Now sine, you might remember, is y over r. So that's going to be negative 3 over the square root of 13. As always, we have to simplify our radicals. So radical 13 over itself, multiplying. This is going to be negative 3 radical 13 over plain old 13. Cosine now is x over r, so that's negative 2 over root 13. And same deal as with sine, we need to simplify that radical, so that'll be negative 2 root 13 over 13. And now here's the one we get for free. Cotangent is just going to be the flip of whatever tangent was, and with the same signage as well. So cotangent, x over y, is just going to be 2 over 3. I mean, you could say negative 2 over negative 3, but then it becomes positive anyway. And now let's do the other functions. Now, once you've gotten sine, cosine, and tangent, you get the other 3 functions pretty much for free. So we know that cosecant is the reciprocal of sine. So instead of doing negative 3 over radical 13, cosecant, which is r over y, is going to be negative radical 13 over 3. And the nice thing for this one, since the radical's already in the numerator, we don't have to do any fancy rationalizing. Secant is going to be the reciprocal of this, r over x. So that means we're going to have negative radical 13 over 2. We'll do one more of these. Pause the video and try this one on your own. Get as far as you can. So sine is y over r, which means they gave us the y value and the r value. We are here in quadrant 2 between 90 degrees and 180. We know in quadrant 2 the y value is positive and r value is positive anyway. Since we know r has to be positive, if the whole fraction comes out positive, automatically we know y is positive. So we have a y value of 5, r value of 13. Let's use Pythagorean theorem to get the x value. So now we need the square root of r squared minus y squared because we're looking for x. So that's the square root of 13 squared minus 5 squared. That's 169 minus 25. So that's the square root of 144, which is 12. But we do need to be careful here. Whenever you are calculating an x or a y value, remember it can be positive or negative. So let's look back at the quadrant. We're in quadrant 2. Is x positive or negative in quadrant 2? X is negative over there. So that means rather than writing positive 12 down here, we're going to have to write negative 12. Because again, negative x in quadrant 2. All right, let's get our other trig values. So let's do the easy one first, cosecant. That's the reciprocal of sine. So that's going to be 13 over 5. And if you could get nothing else right on like one of these questions on a test, you at least better be able to get the reciprocal of the original function, right? All right, so cosine now, x over r. So we've got negative 12 over 13. Tangent, y over x. That's 5 over negative 12, so negative 5/12. Secant, r over x. That's just the reciprocal of cosine, negative 13 over 12. And then cotangent, x over y, reciprocal of tangent, so negative 12 over 5. Well, that's it for this one. Time flies when you're having functions. Till next time, this is Mr. Sutton, signing off.